Okay, so I'm going to go over some problems from 6.5 Gas Laws Review Sheet. Okay, first ones I'm going to go over are some of the conversion problems, numbers 10, 11, 16, and 17. Okay, first let's go over the pressure conversions. Okay, number 10, I'm going to do the work down here. Okay, your known is 0.90 atmospheres, and we need to convert that to millimeters of mercury. So right here, we need to find a conversion factor for that. If you look at your reference sheet, which I so conveniently have right here, it tells us that 1 atmosphere is equal to 760 millimeters of mercury. So first, I want to cross out the atmosphere. So I'm going to put 1 atmosphere on the bottom, and then the 760 millimeters of mercury would go on top. Then the atmosphere units cancel out with the atmosphere units, and I have 0.90 atmospheres times 760 millimeters mercury divided by 1 atmosphere, so basically just 0.9 times 760. Grab my calculator. 0.9 times 760 gives me 684. So my answer for this problem is 684 millimeters of mercury. Yep. So write that right here, 684 millimeters of mercury. Okay. Let's go ahead and try number 11. Okay. Number 11, we're converting from Kpa to atmospheres. So, same process. We're going to start with our known, 603.9 Kpa, and then we need to find a conversion factor. If we look on our pressure conversions, 1 atmosphere is equal to 101.325 Kpa. Since we want the Kpa to cancel out, we put it on the bottom. 101.325. And then 1 atmosphere will go on top. The Kpa and the Kpa cancel out, so we have 603 times 1 divided by 101.325. Grab my calculator. 603.9 divided by 101.325 gives me 5.96. Okay, so 5.96 atmospheres will be our answer. Okay, now let's go ahead and go over some of the temperature conversions. Okay, most of the time we'll be converting from Celsius to Kelvin. Okay, that conversion factor is also on your conversion sheet, right there. Kelvin equals the degrees Celsius plus 273. So number 16 is negative 150 plus 273. Okay, easier way to write that is like that. Okay, it's the same thing. 3, 2, 1. So negative 150 degrees Celsius is 123 Kelvin. Okay, for number 17, we have 25 degrees Celsius plus 273, 8, 9, 298 Kelvin is our answer. So pressure conversions are pretty basic, just the degrees Celsius plus 273. These conversions will be important when doing harder gas law problems where you have to convert before you can plug in the numbers and solve. So let's go ahead and flip to the back of the review sheet, and we're going to go over some of the problems there. Like number 24. The pressure inside a container of carbon dioxide gas is 600 millimeters of mercury at 300 Kelvin. If the volume remains the same and the temperature is increased to 500 Kelvin, what will the resulting pressure of the carbon dioxide be? Okay? Because there is a change happening, we know it's going to be a combined gas law problem. The combined gas law is P1 V1 over T1 equals P2 V2 over T2. Okay? And that equation is given on your reference sheet. Okay? This problem also says that the volume remains the same. So if the volume remains the same, we don't need to worry about it, and we can just, erase it from the equation. Okay, so our new equation is P1 over T1 equals P2 over T2. So let's go ahead and write out our variables. P1 equals, T1 equals, P2 equals, T2 equals. Pressure 1 is 600 millimeters of mercury. Okay. Temperature 1 is 300 Kelvin. The temperature D is increased to 500 Kelvin, and it's asking us for the new pressure. It doesn't specify a unit, so we do not have to convert. The only time you'll have to convert in a combined gas law problem is when you're converting to Kelvin. You need Kelvin. But the pressure, it doesn't really matter which units it's in. So let's go ahead and plug it into our equation. P1 is 600 millimeters of mercury over T1, 300 Kelvin, equals P2 over 500 Kelvin. Okay, to get the P2 by itself, since it's divided on this side, we're going to have to multiply it. So times this side by 500 Kelvin, so that cancels out. Whatever you do to one side, you got to do to the other, times 500 Kelvin. And our new equation becomes 500 Kelvin times 600 millimeters of mercury over 300 Kelvin equals P2. The Kelvin units cancel out, so we're left with just millimeters of mercury, which is cool because that's what we want. And then we can just plug it into the calculator. 500 times 600 equals 300,000 divided by 300, and we get 1,000. So the answer is 1,000 millimeters of mercury. Okay, let's go ahead and take a look at another problem. Number 30 says, what is the volume of a 0.91 moles of a gas at STP? Okay, so this one's a little bit more confusing. Okay, so it's confusing because it doesn't have that much information. It's asking you for volume, it gives you the number of moles, and then this, STP. STP is standard temperature and pressure. Okay, this is something you need to memorize the values of. Standard temp is 0 degrees Celsius or 273 Kelvin, and standard pressure is 1 atmosphere. So by saying at STP, it's giving you the temperature and the pressure. Okay, it's only talking about one sample, so this is going to be a pervert problem. So let's go ahead and write out our variables. P equals, V equals, N equals, R equals, T equals. Okay, our pressure is 1 atmosphere. Our volume is what we're trying to find. That's what it asked us for. N is number of moles. That's 0.91 moles. R is always 0.0821 liter atmospheres over moles Kelvin. And T, we want it in Kelvin, so it's 273 Kelvin. Okay. Now, if we need to solve for V, we have to move this P to the other side of the equation. So if it's multiplied here, you're going to divide here, and the equation becomes V equals nRT over P. Okay, so now we have our equation, and we just have to plug things in. So V equals N, 0.91 moles, times R, 0.0821 liter atmospheres over moles Kelvin, times T, 273 K, all over P, 1 ATM. Okay, I'll put it to print. Okay, now we can cancel out units that are the same, mole and mole, atmosphere, atmosphere, Kelvin, Kelvin. We're left with liters, which is cool because that's a unit for volume, which is what we want. And we just have to plug into our calculator. So we have 0.91, 91 times 0.0821 times 273 equals 20.39, you can divide by 1, but divide by 1 just gives you the same answer. Okay, so our answer is 20.4. Okay, because all of our knowns only had 2 significant figures, we would actually report that as just 20 liters. And that is our answer. Okay, let's look at one more problem. Wait, 2 more problems? Nope, 1 more problem. Okay, looking at number 27, which says a 0.250 atmosphere and 50-degree sample of a gas occupies 120 liters. What volume does it occupy at 0.5 atmospheres and 10 degrees Celsius? Okay, this one again has to do with a change, which means it's a combined gas law problem, which is P1 V1 over T1 equals P2 V2 over T2. Now, normally when we do these problems, something is remaining constant, but in this, nothing is remaining constant. Okay? The volume, the pressure, and the temperature are all changing. So we're going to have to use all of the variables. P1 equals V1 equals T1 equals P2 equals V2 equals and T2 equals. Okay? P1 is 0.250 atmospheres. Okay, 15 degrees Celsius, that's going to be T1. V1 is 120 liters. P2 is 0.500 atmospheres. T2 is 10 degrees Celsius, and V2 is what we're trying to find. The only conversion we have to do here is to convert the temperature into Kelvin. So we're going to add 273 to both of these, and we get 288 Kelvin and 283 Kelvin. Okay, so that is the values of T1 and T2 that we're going to use. Okay, and now we just have to plug things in. P1, 0.250 atmospheres times V1, 120 liters, over T1, 288 K, equals, shoot, that is going to get in the way. I'm going to rewrite it over more. Okay. P1, 0.250 atmospheres over V1, 120 liters, over T1, 288 Kelvin, equals P2, 0.500 atmospheres, over times V2, over 283K. Now this just gets into some fairly complicated algebra. For this, probably the easiest way to start would be to cross multiply. Okay, so I'm timesing this number by this number by this number and setting it equal to this times this times this. Okay. So when I do that, I'm going to enter it slowly onto the calculator. 0.250 times 120 times 283. Okay, so that's this number times this number times this number. It's all right there. Equals 8,8490. And so we're not using the units. I'm going to go ahead and put them here. Atmospheres, liters, and Kelvin. Set that equal to these three things. So 0.5 times 288. We can't times it by V2. That's our variable. That's our unknown. And we get 144 atmospheres Kelvin times V2. In order to get the V2 by itself, we need to divide both sides by 144 atmosphere Kelvin, 144 atmosphere Kelvin. Okay, and you'll see that all of this cancels out. Atmospheres cancels out with atmospheres. Kelvin cancels out with Kelvin. You're left with liters, which is cool because that's a volume measurement. And we just have 8,490 divided by 144. So we plug that in. 8,490 divided by 144 equals 58.96 liters is equal to V2. And because all of these, the last one had 2 sig figs, we would just round this to 59 liters. And that would be our answer. Okay. And there's some problems from the review sheet. Get it done, and I will see you on Monday or Tuesday for the test. Dun, dun, dun.